and welcome to Coffee Table Physics. I'm Riley.
And I'm Jonathan. The reason you're probably here is because you wondered, like us, where does space actually start?
I mean, we know from sci-fi movies that space is cold, dark and has no air. Very different from our relatively warm and sunny existence down here on Earth.
So, the Earth is surrounded by a layer of gases, mainly oxygen, nitrogen and carbon dioxide, called the atmosphere. Consider a slab of air in the atmosphere. There are three main forces acting on it. Its weight acting downwards, the force of air pressure from below acting upwards, and the force of air pressure from above, different to the pressure from below, acting downwards.
Now, from Newton's first law, we know that the forces acting downwards must balance the forces acting upwards in order for the slab to be in equilibrium, meaning it's not accelerating up or down. Therefore, the weight of the slab plus the air pressure from above must equal the air pressure from below. We can learn from this that the pressure pushing down from above must be lower than the air pressure below the slab. As the slab can be at any height, we have shown that air pressure decreases with height.
If we analyse our slab a bit further, we would see that the rate of decrease of pressure with height is proportional to the density of air. Both pressure and density are proportional to the number of air molecules we have in a given volume. This is known as the number density and is a measure of how thin the air is. We can then say that the number density decreases with height at a rate proportional to number density. This means that if we double the number density, the air will get thinner twice as quickly as you gain altitude.
You may be familiar with this if you are a keen mountaineer. The air gets thinner with altitude to the point that if you were to try to climb Mount Everest, you would need to bring an oxygen supply with you.
The fact that the rate of change of number density with height is proportional to number density is very special to mathematicians and physicists. It means that number density shows an exponential decay with height.
But what is an exponential decay, I hear you ask? An exponential decay looks like this. The number density keeps decreasing and decreasing and decreasing, but, crucially, doesn't reach zero. This exponential decay crops up all over physics, most notably in radioactive decay. The rate at which radiation is spat out by a radioactive sample decreases over time as the supply of radioactive atoms runs out. However, this will never reach zero, theoretically.
And now we reach the punchline of our answer. The fact is, technically, the atmosphere never stops, as there's always a chance that we could see a lonely oxygen molecule at any height above the Earth's surface, even on the other side of the solar system. There is no set point at which space starts.
So you're now probably feeling a bit cheated. I mean, if an astronaut is orbiting the moon, they're obviously in space. You'll say, why are you not giving me a proper answer to my question? Well, we're not saying that space doesn't exist, it's just that the boundary between space and not space is a bit hazy.
To give you more of a definitive answer, the Kármán line at 100 kilometres above sea level is often used as the start of outer space, such as in the Outer Space Treaty.
Yes, that's a thing.
The Kármán line lies within a region of the Earth's atmosphere called the thermosphere, where temperatures can reach as high as 2,000 degrees due to the absorption of radiation from the sun. It's in the thermosphere that the northern and southern lights occur.
It may surprise you to learn that the thermosphere is not the outermost layer of the atmosphere. In fact, the highest layer of the atmosphere is called the exosphere, which starts at an altitude of around 1,000 kilometres. This is composed of mainly hydrogen and helium, like most of outer space. We often put Earth-orbiting satellites in the exosphere.
We should probably also mention the other layers of the atmosphere as well. The troposphere is the lowest layer and is the bit where we live and where almost all of our weather occurs.
Above the troposphere, from 10 to 50 kilometres, is the stratosphere. This is where we find the ozone layer and where commercial aeroplanes fly.
And between the stratosphere and the thermosphere, from 50 to 85 kilometres, is the mesosphere. Much about this layer is unknown, as it lies above where planes or weather balloons can reach, but below where satellites orbit. One thing we do know, though, is it's where we often observe meteors or shooting stars.
And so we reach the end. Now next time you're staring up at the night sky, you'll know that there really is no invisible dividing line between you and the vastness of space.
Thanks for joining us. If you have any thoughts on the video, feel free to leave them in the comments box.
Plus, tell us if there's something about this wonderful world around us that you think, I want to know what's going on here. We would love to help.
See you here next week.
Same time, same place.
Cheerio.